Okay, here's some homework help for the sine application questions. First question asks for the maximum and minimum values of the function. Now, we spent most of our time looking at sine functions, but it turns out cos functions, everything functions the same. It's just that they're off phase a little bit. For a sine graph, they start here and go up like this, and they keep going, of course, both ways. Cos graphs start here, and they go down. If I make sure I'm doing this right, and they come up and sort of stop right there. And they do keep going. So they look the same, it's just that the cos one is shifted over a little bit. So maximum and minimum values should be the same for each of them. It's just that they would reach those max and min values at different points. Okay, so a normal cos graph starts here at 1 and goes down and comes back up and finishes at 1. Okay, the midline is here is the x-axis. So if they want to know how high up the thing goes, first thing I would look at maybe is, I guess I can look at this stuff here, but all of the stuff inside the brackets is just affecting x values left and right. It's these outside a and d values that affect the y values, and that would be a minimum or maximum value. So let's start with this one here, a 3. So instead of starting at 1, the graph would start at 3. So it would be up there at 3, and it would come down to a negative 3, and then come back up to a positive 3. Having a plus 3 on the end here says to move that graph all the way up, move the same thing up 3 units. So I don't know if I can move that. There I go. So then instead of starting here at 3, I got to go up 3. So there's 4, 5, and 6. So I'd start at 6, and then I'd come down. Let me make sure I'm doing this right. So I'd come down and then go back up and finish there. Now, this stuff here would have moved the thing left or right, but that doesn't matter for min or max. So it looks like I can get up to 6, and my minimum will be 0. So the max would be 6, min would be 0. Let's just confirm this by plotting it in decimals. Okay, I've graphed it here, and take a look at what's happening. Looks like, sure enough, the maximum value of this graph is at 6, and the minimum value down here is at 0. Notice the graph has horizontally squished, and that would be the responsibility of the 5 there. And the graph is also moved over to the right by pi over 2. Okay, so that's the first question. The second question, again, is a cos graph, but like I said before, the amplitude, phase shift, etc., you find them all the same with cos graphs or sine graphs. So if they ask for the amplitude is simply the number out front there is 5,000. The period is always 2 pi over b. So it'd be 2 pi over, the b value is this thing right there. So that's pi over 60. Now I can't leave it like that. Let's rewrite it like this. 2 pi divided by pi over 60, which is the same as 2 pi times 60 over pi, doing the invert and multiply. So the pi's cancel, and 2 times 60 is 120. So the period would be 120. And then the phase shift is c over b. So it's phase shift is c over b. So the value of c is 10, and the value of b is pi over 60. Well, I'm going to have to do that same thing. So it'll be 10 times 60 over pi, or 600 over pi. And I'd probably leave it just like that there. Question 3 is an interesting one. They throw the number e in there, so like logarithms or exponential functions, I'm liking it, involved with a cos graph. And they're taking a spring and they're letting it go, and it's falling, coming back up and falling, and then just getting smaller and smaller. So it's not a normal cos or sine graph because it's getting smaller, but you see that same kind of wave thing. So the question says, how far do you think the spring is from the ceiling when the spring stops bobbing? So they have a ceiling and they have something here and they have the spring right there, and there must be something on bottom of it. There's a weight, and they let that sort of bounce up and down until it stops. And they ask how far from the ceiling is the spring when it stops. When I take a look at this one, I'm having sort of a hard time figuring that out. I guess it's a cos graph, so cos graphs start at 1 and go down to a -1 and then come back up. The amplitude is changed by this amount, and that's sort of an exponential amount, so it's gonna, and since this is negative, it's gonna get sort of smaller and smaller. So I'm not sure if that's gonna help me out a whole lot. And then I have a +3 there. Why don't we, rather than try and fight with that, let's just try and graph it. So get out Desmos and graph it and see what the graph looks like. Okay, here's what I got when I graphed it. It looks a little crazy. Now, notice that I typed it out, and instead of a d of t, I just put in a y, and instead of putting a t in there, in here and in here, I put x's for each of those things. But let's explore this graph a little bit. One thing that bothers me a little bit is that it's showing me all this negative stuff. And the negative stuff would be a negative time, and that's not applicable. So I'm just going to sort of get rid of that stuff. And then I'm going to sort of maybe make it a little bit bigger, see what sort of happens there. Okay, so you see the graph, and it would be like you would think. The spring initially would be quite large, and it would just get smaller and smaller and smaller and smaller. Okay, so now they're asking about where do you think that this thing stops? Well, when I take a look at the graph, it looks like it's shutting her down right about at that number there. So if I look up, this is 1, this is 2, this is 3, it looks like it's shutting down at 3 units away from the ceiling. And I guess what I could do from that, deduce from that, is if I take this stuff out front, and that's sort of the bounce, the amplitude of the graph, if it shrinks down to 0, then this would be 0 times anything would be 0, and 0 plus 3 comes out to be 3. So that makes my graph make a little bit of sense. Okay, this next question asks for us to look at this average temperature, and I want to graph this function, and they say they want to graph it for between 1 and 12, and that's what they have on the graphs down here. So they want to see what it looks like. Average monthly temperature, and they have January to, I guess, to December. So if we were in Canada, we'd have a very low temperature, and then it would go high, and then it would come back down. So this would be January, this would be here in July or August sometime, and then finally in December get back cold. Let's just plug this in and into Desmos and see what kind of graph we come up with for it. Okay, I've graphed it, and I don't see it. Oh, it says plus 37. It's probably way up high. Whoops. Let's shrink it and just see if we can find that graph. Oh, there it's coming. Here we go. Here we go. And they say they want to know what the graph looks like from 1 to 12. Okay, I'll just make this a little bit bigger. Oh, I have too much there. There. Okay, so from 1 to 12. There. It's better. Okay, so from 1, that's from here, so that's that point right there, to 12, which is this point, right about there. Doesn't look like it finishes one whole period, but it's close to it. So this graph looks like it's very similar to the one that I had. So it starts cold, it gets real warm, and then cools off. And so let's look at the questions that they have. So they say graph the function and choose which one it looks like. I'm thinking it looks like that one. The highest average monthly temperature, you can't really see it on the graph there, but let's take a look. Right about there, highest temperature, I don't know, would that be 51-ish? Around 51. You could maybe zoom in a little bit more on the graph, or maybe we can tap on it. I wonder if decimals will let us do that. Let's try it. Oh, it does. 51, yep. So on the 7th month, 51. Highest temperature is 51. The highest average temperature occurs in, it was 7, so that'd be July. July. Okay, that's good. So I'm looking at applications of sine functions. The last one, we have to do a little bit more work. So they give us a table, and they say, take a look at that and see if you can use regression to determine the function. And they give us a bunch of them right here, and I want to know which one it is. They're all fairly close, and so I'm going to have to be fairly careful with my stuff. Okay, so what I want you to do is grab your decimals. Here's my decimals. And I'm going to go in and I'm going to type in all of this data. It's going to take a while, but I'll pause. You type it in, I'll type it in. And then we're going to use regression to try and find out which of those functions it would be. Okay, so I'm, to do the table, remember you hit that plus sign right there, and then you hit table. And then you should start entering stuff in. You do it, I'll do it, we'll come back. Okay, hope you've got all your numbers typed in. I've got them here. Let me make this a little bit bigger. Can't really see the numbers. Let me start, whoops. Make this bigger. But I need to shrink the graph. There we go. Oh, there's the numbers starting right there. Okay, so I want that fairly big. And now what I'll do is I'll enter an expression, and it's a general sinusoidal graph. So it'll be y is equal to a sine b bracket x minus c over b, whoops, c over b over bracket plus d. There. And I want a slider for all of them. Good. So you see the black sine graph at the bottom, barely a bump. And what I want to do is make that look like the green dots, or follow as many of those green dots as I can. Okay, so my amplitude, I need more amplitude. So I tap on the 10 and then say, let's go to maybe 55. Give ourselves a bit of room. Okay, so let's make that 55. That's looking a bit better. Let's bring it up. Oh, not enough room. Let's change that to, again, 55. Probably will do it. So, bringing it up. Oh, up a little high. Right in there somewhere. Okay. My B value, I need to make it a bit bigger. That's looking pretty close there, 0.2. And I think that was one of the numbers that they had for all of them. So we'll leave that B as 0.2. Then C, let's move that one way. Oh, probably it's easier to move it this way. There. I'm getting pretty close there, hey? No, remember that the negative for a C value in the equation will manifest itself as a positive. So I've got about 1.6 there. That's fairly close. maybe it should go over just a touch. 1.7, a touch much. Maybe 1.65-ish. That's looking pretty close. I'm using that number because I think that's one of the numbers that they had. Okay, and then it looks like my amplitude's a bit high. 55 might be a little high. Let's go down to 50. A little low. Maybe 51. I'm pretty happy. Right in there somewhere. Okay, now let's move this out and see what answers they have. Okay, for amplitude, they've got either 50 or 51.39. I quite like the 51, but let's 51, let's try 0.39. Yeah, that's looking pretty good there. Let's try 50 just to see. And 50 is not too bad either. Maybe it's a touch low, but if I had to choose, I'd probably go with the 51.39. Just a little closer. The B value for all of them are 0.2, and I've got 0.2, so that's good. And then C value, I have negative 1.65, which in the equation would be a positive 1.65. And they do have that as one of the options. Let's just play, though, and see what happens if I go 5, 6 there. Oh, see, it's a little off, like the line doesn't go right through the dots. So I'm thinking 6, 5 might be a little bit better. Okay, and then the D value, I've moved it up. 50 looks awfully good. And they have 50.01, but let's try doing 51.39. That's the moving up one. See, that's not horrible either. Let's go back to the 50.01. Both of those are pretty close. On a test, I'm probably going to give you either one of those because they're very, very close to the numbers that are there. If I had to sort of pick one, I might just pick that 50.01. Okay, so that gives you an idea of what I'd like you to do with the regression. Is you type in your data, type in that general formula, and play with the A, B, C, and D until you finally come up with a function or a line that approximates most of those dots. All right, hopefully that helps you with your homework for this section.